All right, hello everybody. We're going to go ahead and get started here. Today, we're going to be talking about our first series of climate change impacts, and we're going to be focusing on aquatic ecosystems. So we're going to be looking at things like pH, temperature, and dissolved oxygen changes, and how this affects biodiversity in aquatic ecosystems. So just a reminder, we talked about this extensively in Unit 2, but when we talk about biodiversity and organisms surviving changes to their climate, tolerance range is something that's going to be very important. So your tolerance range is going to be a measurement of the conditions in which a population, an individual organism, or a species as a whole can survive in without being pushed to extinction. So remember, we have those optimal zones, those zones of stress, and the zones of intolerance. If you need a recap on any of those, highly recommend you go back to Unit 2 and rewatch the tolerance range videos. Now, climate change, as it currently occurs, is occurring much faster than organisms can adapt to. Remember, climate change can be natural. The climate of Earth has changed rapidly. Well, maybe not rapidly, but dramatically over its history. But typically, this change is very slow. So organisms have time through natural selection to adapt to any type of changes that occur in their environment. However, humans have been causing climate change to occur at such a pace that evolution is not really able to keep up with the pace at which we change our climate. The first way that climate change is impacting aquatic ecosystems is by affecting the pH of different aquatic ecosystems. So just remember, pH is a measurement of the acidity of water solutions. In other words, it's a measurement of what is your concentration of hydrogen ions, i.e. protons. Hydrogen ions are highly attractive, which is why acids are so good at dissolving things, because they're really good at attaching and breaking down objects. And the reason this applies to climate change is because when we have carbon dioxide, which is our main greenhouse gas, and it combines with water in aquatic ecosystems, it's going to form something called carbonic acid. And this carbonic acid is going to help make these free-floating hydrogen ions. So the addition of CO2, which is being diffused into water, is creating an acidic environment in ocean ecosystems. So here we have a graph that shows the CO2 levels, one of those key greenhouse gases, and how it has changed over time. So you can see a moderate increase from when the measurements began. And then the pH of water is decreasing, which means it's becoming more acidic as well. So they are inversely correlated. Now, this carbonic acid, or the acidity of the ocean water, is going to have a few impacts. The first of which is that it breaks down calcium carbonate, which is what a lot of aquatic ecosystems make their homes or their skeletal systems out of. So things like amniotic shells that we have here, but also these coral species here as well are made of calcium carbonate, which get dissolved by the carbonic acid. Now, besides carbonic acid, oceans also absorb excess heat that is trapped by greenhouse gases. So here shows the average temperature of the ocean from the 1880s till today. And we can see a rapid increase starting in the 1960s as CO2 levels began to increase as well. Now, some keystone species in ecosystems, especially coral reefs, cannot take this excess heat. The mutualistic relationship that coral has with zooxanthellae tends to break down when the heat is too high, and it results in something called coral bleaching. So we are removing this keystone species from this ecosystem, and this is caused in trophic cascades in order to cause a breakdown in the food webs that exist here. Now, another part of this goes back to what we talked about in Unit 8, which is the idea that warmer waters also hold less dissolved oxygen. So as the ocean warms up, it's going to hold less dissolved oxygen, which is going to increase the amount of dead zones that we have in these aquatic ecosystems as well. So here's kind of a figure to kind of wrap up everything that we just talked about. So we start with the orange over on the left, and it says human activities raise greenhouse gases. One of these greenhouse gases is carbon dioxide. Carbon dioxide diffuses into ocean waters, which increases the acidity through carbonic acid, which results in a decrease in biodiversity. Human activities raise greenhouse gases in atmosphere. Greenhouse gases raise temperature in lower atmosphere. Ocean absorbs that heat, and that's going to result in two consequences. First, the ocean temperature rises, and second, warm water holds less oxygen, which decreases dissolved oxygen, and then biodiversity decreases. So we can see our three main pathways in which climate change is causing a decrease in biodiversity in aquatic ecosystems. So that's going to be it for today. We'll do an activity to kind of work with some of these tomorrow, and I will see you then.